The exhibition, Conqueror's Prize, the Battle at Narva 1700, opens in October 2018 here at the Army Museum. And by then, 28 colours and pennants shall undergo conservation and be made ready for exhibition. The regimental colours were taken by the Swedish Army as trophies during the Battle of Narva against the Russians. We will follow the conservation of 3 objects. A Streltsy colour, which is painted on both faces, made of silk taffeta and with coloured parts in intarsia. The second banner is a company colour made in Chinese silk damask with pattern shapes worked in intarsia. It is also painted on both faces. The third is a small lance colour, also known as a pennant, made in silk taffeta, again painted on both faces. The colours show damage that needs treatment. They have become deformed after hanging for a long time in the Riddarholmen church, are very dirty and torn and show damage due to exposure to light, which is seen as diagonal rays across the cloth. Some of the material is quite stiff, so that at the border between painted and unpainted surfaces, the material is extra sensitive, resulting in ruptures. Intarsia in textiles are patterns and figures formed by sewing together small pieces of fabric in different shapes and colours with small overlapping seams. The use of intarsia has resulted in deformation of the banners as a result of tensions at the seams between the joined pieces, especially in the zigzag pattern. To be able to exhibit the colours, they need conservation treatment. A support in the form of a new fabric layer is required. To apply this new fabric to the colour, it must be clean, or at least cleaner, and flatter. Previously, when colours have been washed in a water bath, the painting has been protected by covering it in beeswax dissolved in turpentine. An effective method that has protected the painting, but is hazardous to health, makes the paint colours darker, and the beeswax itself is impossible to remove. To gain more knowledge about the material and to be able to develop suitable conservation methods, I travelled to the Swedish Heritage Board in Visby, with 3 carefully packed banners. As a guest colleague, I would get help in the Cultural Heritage Laboratory with analysis of the material. Once in place, small samples of both the painting and textiles were taken. Here, a sample from the weft thread of the Streltsy colour weave is taken. And here, from the gold paint in the star on the company colour. To get clear cross-sections of the paint samples, they are cast in resin and hardened in UV light to then be polished. Under the microscope, it is possible to see how the paint layers have been built up. This is a sample from one of the angels in the Streltsy colour. In the middle of the sample, the red silk of the warp and weft are covered with a thin primer and then a paint layer, with a layer of gold on top of this. Here is the same sample viewed under UV light, making it easier to distinguish certain details. Under a USB microscope, the sensitivity of the paint to handling and water was investigated. Here, a small amount of deionized water is placed onto the Streltsy colour and a cotton bud is rolled over the surface. Very small flakes of paint are detached. To be able to wet clean the colour in a gentle way without using beeswax, cyclododecane and a microcrystalline wax were tested to see if they were sufficiently water repellent and protected the paint layer. Cyclododecane is a synthetic wax that evaporates after a while, and microcrystalline wax does not yellow in the same way as beeswax, but is also impossible to remove. The adhesive paralloid B72 is insoluble in water, so trials were also made using this in combination with the 2 waxes. A known use of paralloid B72 is as a protective varnish on paintings. Using a marker pen, water-soluble ink was painted onto the silk fabric, and the contours of the ink outlined with pencil. When the ink had dried, it was covered with different variations. Cyclododecane on one face, on both faces, a single layer, 2 layers, cyclododecane with paralloid B72 on top, and so on. Here, the ink is covered with cyclododecane that melts at 65 degrees and needs to be applied relatively quickly to avoid cooling and hardening. To apply paralloid B72 in a controlled manner is difficult. It flows easily over the edges of the cyclododecane and out onto the silk fabric, where it is impossible to remove without the use of solvents. To see how waterproof the different combinations are, water is dropped onto the test samples, which are then covered with filter paper and allowed to dry under a glass plate. Here, the dry samples are checked, and it is possible to see which combination was able to protect the ink and which have bled. To look more closely at the result of the different treatments, the test pieces were studied using a light microscope. Using the microscope, it is easy to see if the ink had bled beyond the pencil contours. The results show that cyclododecane in 1 or 2 layers only has very small colour bleeds, and that those which included paralloid B72 show no bleeding at all. But if the paralloid is outside of the ink, it's not possible to remove it. It had been thought that it would be easy to lift away once the cyclododecane had evaporated. Using micro-XRF, it is possible to carry out non-destructive material analysis on a very small surface. Here, on the Saint's harness on the Streltsy colour, we looked at the silver paint, which proved to be lead white, and the halo shows high levels of gold. We also looked at material in the pennant, such as the paint on the eagle's wings and on its label. To investigate the binder in the paint, ATR-FTIR mapping was used. To run the instrument, the detector is first cooled with liquid nitrogen. A cast paint sample is placed in the FTI instrument, and the results indicate that both the primer and painting are done with an oil-based binder. The presence of lead, and also kaolinite, usual in primers, is identified. We also investigated the cast paint samples in a scanning electron microscope to look at metal content and could determine gold, silver, copper and lead. It was also interesting to take a closer look at the weft threads from the Streltsy colour in the scanning electron microscope. A specimen stub with weft threads is mounted. Here is one of the blue weft threads. The fibres are in poor condition and have many breaks. The small dirt particles on the thread were found to contain aluminium, calcium, silicone and sulphur, probably pollutants from when the banner was exhibited in the Ridderholmen Church for many years. Tests carried out to investigate the tensile strength of the silk showed the fragile threads only retain a small amount of their original strength, in spite of their relatively good appearance. The results also indicate that the blue threads are maybe a little better preserved than the yellow. After all the analysis and investigation, it was time to pack up everything and travel home to the Army Museum. I now know that the painting is oil-based, and therefore not water-soluble, but I also know that the painting is fragile, and the silk in the Streltsy colour is very, very fragile. And I know that cyclododecane is a good protector of the paint from water. Now the colours will be unpacked and conserved. They will be surface cleaned with careful vacuum cleaning and a dry, soft sponge. Here, one corner of the Streltsy colour is being cleaned. A lot of dirt transfers to the sponge, but this must be done carefully so as not to further damage the silk. Here, the pennant is carefully vacuum cleaned using a mini mouthpiece, and then carefully cleaned using a soft, dry sponge. The painting is cleaned with saliva on a cotton bud. The painting is very sensitive, but it is important to remove the dirt for both aesthetic and preservation reasons. The dirty fringe on the pennant's sleeve is cleaned with a cotton bud and deionized water. The dirty water is soaked up using blotting paper and the fringe is carefully laid out. The company colour is also carefully vacuum cleaned and treated with a dry sponge. This banner will be washed in a water bath in a more traditional way and must be prepared beforehand. The silk fabric is in relatively good condition but is very dirty and wrinkled. The banner's stave has been removed, but even the sleeve that the stave sits in needs to be removed in order to conserve the banner. It is important to mark where the sleeve was positioned so that it can be repositioned correctly. The surface closest to the sleeve is damaged and fragmented. The banner is laid carefully on the washing table, on a plastic sheet to allow easy turning after the painting on one face has been covered with cyclododecane. Cyclododecane is melted in a water bath, and since it hardens quickly when the temperature drops, it needs to be reheated often. Cyclododecane is brushed onto the painting. Here, areas with gold paint and oil-based paint are covered. The paint and gold otherwise risk flaking during wet cleaning. The black contours are painted in gouache, and the colour has penetrated the silk, making it less sensitive to mechanical abrasion than the other paint. It is also, of course, not water-soluble. The banner is then carefully turned and the painting on reverse is also covered with cyclododecane. The part of the banner that is very damaged with small loose fragments is covered with an open polyester fabric during washing to give added protection. Wet cleaning starts. The banner is wetted out with deionized water and a small amount of surfactant. Careful sponging begins. The banner is rinsed carefully to remove dirt and surfactant. Water is sponged away and the procedure is repeated several times with clean rinse water. A shower is used to rinse away the washing water. After the final rinse, as much water as possible is removed by sponging. Polyester fabric is removed from the delicate area, and now the banner and broken fabrics must be positioned correctly. Ensuring the banner regains its original shape is a time-consuming step. To help get the banner square, a thread is tied in position over the cross. When the silk fabric has dried, it is not possible to reshape it without wetting it again. The banner is left to dry on the washing table. This is the washing water, the different rinse baths and sponges used during surface cleaning. When the banner is dried, it must be released very carefully from the table, as it is stuck fast to the surface. The newly washed and dry banner is placed under an extractor so that the cyclododecane will evaporate as quickly as possible. This takes 3 weeks, and then the banner is turned to allow the cyclododecane on the reverse to evaporate. The sleeve from the green company colours is washed separately. Deionized water and surfactant are used. The sleeve in wool is less fragile than the banner cloth and can take a little more agitation. Now it is the turn of the pennant to be cleaned and flattened. Since the painting is sensitive, we want to moisten the silk in the pennant under controlled conditions and carefully wet only the fabric without the painting becoming wet. To better be able to feel how much the fabric can be manipulated, we work without gloves. There is blotting paper directly under the pennant to capture dirt and moisture. The blotting paper is masked with Melinex where there is painting on the pennant to avoid wetting the painting. Melinex is a plastic available in different thicknesses and has various uses in textile conservation. The pennant is flattened step by step and blotting paper is also pressed against the top face to remove dirt. Weights are positioned to keep the cleaned and flattened parts in place. After a while the weights are removed and the blotting paper carefully lifted away. Now that the pennant is a little cleaner and flatter, it will be treated under pressure on a suction table to get an even better result. The suction table is switched on and Melinex is rolled out over the pennant with a pressure of 40 bars until dry. When flattened and smooth, a new fabric layer will be added to give support and strength. Now, the cleaning and flattening of the Streltsy colour starts. To protect the painting from the deionized water, here we use cyclic silicone instead, cyclometicone D5, which repels water and which evaporates after 2 hours. The border of the fly side is the most damaged side, and it takes a long time to carefully clean and flatten it out, a process that must be repeated several times. Deionized water is sponged on, and on the underside blotting paper soaks up the dirty water. To keep the fragments in place and flat, weights are applied before Melinex is spread over and the suction table switched on to dry the border and smooth it flat. The weights are repositioned as the Melinex is rolled away. Lines of dirt build at the border with the area that has not been cleaned yet. These are worked on step by step with deionized water and cotton buds. To be able to control the damaged fringe and enable handling after it has been smoothed out and the weights are removed, the fringe is sewn into a Melinex cover. Here we can see when suction and pressure are applied to the surface nearest to the image of the saint. Notice the buckled damaged material, which will also be smoothed out a little later. After the section has been under pressure and dried, the Melinex is carefully rolled off. It is important to make sure that the small fragments are not lifted away with the Melinex. It is not possible to remove all of the creases using the suction table. Some need special treatment with deionized water and a heated spatula. After smoothing, the painting is cleaned with deionized water and cotton buds. Now the banners and pennant will get a support layer of crepeline, a transparent fine silk weave that needs to be dyed to match the colour that it will overlay. It can take many attempts to get exactly the right shade. The goal is that the crepeline blends in as much as possible. The company colours will get a crepeline layer on the whole reverse face, but since one half is more damaged and fragile than the other, only that half will be laminated. On the other half, the crepeline is sewn in place. A 15% water-based adhesive solution is mixed to prepare the dyed crepeline with. The adhesive is rolled onto the crepeline as thinly as possible. When the adhesive has dried, the crepeline is loosened from the Teflon sheet, and the next step is to apply the prepared fabric and position it correctly on the company colours. One face of the pennant will be completely laminated. Adhesive is rolled in a thin layer onto the crepeline, and when it has dried, the prepared fabric is lifted from the Teflon sheet and then placed in the correct position on the pennant. In order for the crepeline to stick to the pennant, the adhesive needs to be activated by heat. Melinex is a protective layer between the spatula and the crepeline. The crepeline has been cut to size and the edges folded so that they can be glued to the reverse of the pennant. For the side of the company colour that will not be laminated, the crepeline is shaped according to the banner's details so that it gets the colour and shape of, for example, a palm leaf that will be covered here. Melinex is placed over the banner and the shape of the palm leaf traced onto it. The plastic template is cut out and the contours are sewn with running stitch in a polyester thread onto the crepeline. The stitching is such that the complete contour is outlined and the thread can be melted in place using a soldering pen. This stops the crepeline from fraying. After this, the finished crepeline is placed on the banner and sewn down. Now the banner has been reinforced by crepeline on both face and reverse sides. A similar method is used with the area around the dragon on the pennant. The pennant is laminated on the complete reverse face, and around the dragon a piece of crepeline is prepared for the top face. The shape of the dragon is cut out so that the crepeline does not spoil the appearance of the painting. Again, a polyester thread is soldered to the edge of the shape, visible as a black outline. The crepeline is pinned in place and then sewn down. This is what the finished result looks like. Here, the banners and pennant have just been mounted in the vault in the exhibition, and to the far right we see the pennant after the completed conservation treatment. When conservation of the company colour is complete, the sleeve is sewn on again and the original position is shown by thread marks. It is apparent that the sleeve needs to be extended as the original seam had gathered the fabric of the banner against the sleeve. The sleeve is sewn in position using oversewing. The conservation treatment of the green company colours is finished and the banner is mounted. Now we will see how the Streltsy colour gets its crepeline support. From one side, the most fragile and damaged parts are laminated. The pieces prepared with adhesive are coloured and shaped according to the intarsia seams where the different coloured parts are joined. Here, the outer fringe is already laminated and one of the blue areas further in on the banner is going to be laminated. To be able to get to the side that will be laminated and to be able to position the prepared crepeline, the banner is passed over a roll and the cut-out crepeline is laid out. At this point there is still Melinex on the upper face of the crepeline as protection against the sticky adhesive layer. Positioning of the crepeline is checked. The crepeline is pinned to hold it in place as the Melinex is rolled off. Now the banner is rolled out over the crepeline, which is sticky side up against the banner. The pins holding the crepeline are removed. When the banner has been rolled out over the glued crepeline, the upper face must be checked and adjusted so that fragments and damaged areas lie correctly. When everything is positioned correctly, it is time to activate the adhesive so that it sticks to the banner properly. Melinex is rolled out as protection for the spatula, and then the spatula, heated to 70 degrees, is passed over the surface. When the banner has been laminated, we have turned the face with partial laminate upwards. Then we roll on crepeline that is sewn on in one piece to give support to the complete banner. Lamination was only carried out on the most damaged and fragile areas. The crepeline is smoothed out, pinned, and then sewn in position. The damaged part of the sleeve also gets support from a new fabric layer. The damaged areas are pinned and secured with conservation stitching. As before, the most damaged areas on this banner will get crepeline support for the top face. A template is drawn up and cut out. Here we have also chosen to fold in the edges of the crepeline instead of melting polyester thread by soldering. The easiest method to create a sharp fold is to press the edges against thick quality Melinex. The edges are cut to give the desired seam allowance. When the crepeline is ready to position, it must be carefully removed from the Melinex template, otherwise it can easily become misshapen. The crepeline is pinned in position and a long, thin, pliable needle is used to secure it with running stitch. The conservation treatment of the banner is finished, and now it will be mounted ready for display. The tears in the painting of the saintly figure are still open and need to be held together during display since the banner will lie on a slightly tilted support. Magnets are mounted in the support board and then covered with silk fabric, which is gentle against the painting. Now the Streltsy colour will be placed in the exhibition. It is still very fragile and the action of moving it to the support board must be done very carefully. The top edge of the banner is pinned in place with thin insect mounting pins. There are still tears in the painting, and these will be held together with magnets during the period of the exhibition. Here we test how the gilded magnets work, and if it is possible to close the tears by using them. The magnets work, and the final solution was also to cover them in crepeline to make them less visible. Here we see the finished display case when all the banners and pennants are in place.